Hey everyone, welcome to the second video on limits for Math 1451 at Texas Tech University, which is Calculus 1. So in our last video, we talked about what limits are, when they don't exist, and we listed some strategies to find when a limit does exist. So in this video, we're going to jump straight into examples of how to calculate limits using these first three strategies, because our fourth strategy uses derivatives, which we haven't learned yet. So we're just going to go ahead and jump right in. So our first example is the limit as x goes to -3 of this fraction. And our first strategy will always be to see, okay, well, does this function have a function value at that point? And see what we get. So I'm just going to plug in -3 straight into my function. So 4 times -3 squared plus 11 times -3 minus 3 over -3 squared minus -3 minus 12. Okay, and then I'm going to go ahead and simplify. So my top I have 4 times 9 minus 11 times 3 minus 3 over 9 plus 3 minus 12. My numerator, I get 36 minus 33 minus 3 over. And I'm going to go ahead and add because we do addition and subtraction left to right. So now 12 minus 12. So now my top 36 minus 33 is 3, and 3 minus 3 is 0. And in my denominator, 12 minus 12 is 0. And this 0 over 0 is what we call an indeterminate value. So in case you forgot what this means, that means that normally when we have a 0 on top of a fraction, 0 divided by anything is 0. However, if we have 0 on the bottom of a fraction, well, we can't divide by 0, so that would be undefined. So the 0 on the top tells us that it should be 0, and the 0 on the bottom tells us it should be undefined. However, there's no good reason to use one rule over the other, so it's actually going to be indeterminate. We're unable to determine what this should be. So to remedy this, we're going to factor out x minus -3 from our numerator and denominator. And you may look at that and see, okay, first of all, why did this lady not just write x plus 3? And that's because we're always going to factor out x minus whatever that point is that we're going to in our limit, which I'm going to call the limit point. So we're always going to try and factor out x minus whatever that limit point is. So that's going to be our goal. To get there, we need to, one, remember how to factor the numerator and denominator. So let's go ahead and just see if that's going to factor in a nice way. So I'm going to go ahead and rewrite my fraction. And so when I have a 4 as the coefficient of my x squared, you can remember this is either going to be x times 4x as our first terms, or 2x times 2x. And so what I'm going to do is I'm going to say, okay, I know I want to try and factor out an x plus 3, x minus -3. So I'm going to start out with an x and a 4x, and I'm going to go ahead and put this plus 3 to see if I can make this work. So I need to have my constant here be a -1, so that I multiply 3 times -3 to give me the -3 as my constant. And then just double check and make sure that works whenever we FOIL it out. And that is how it should work. And then I'm going to go ahead and put an x plus 3 here on the bottom. And in order to get a -12, I need to have a -4 here. And again, just double check when you multiply your outside and your inside, does that cancel to what your middle term should be? And it does. And then we can go ahead and cancel out the x plus 3's. So now I'm going to have a 4x minus 1 over an x minus 4. And that's going to be my new fraction. So I will caution you, just because you know that we're going to need to try and factor out an x plus 3, you need to make sure that this actually factors in this correct way. There will be some questions that we can't end up factoring this out from the numerator and denominator. That may not work out. So just double check your factoring here. So now that we have this new fraction, we're going to evaluate this new fraction at the point x equals -3. So we're going to have 4 times -3 minus 1 over -3 minus 4. So that's going to be -12 minus 1 over -7, which is -13 over -7, which is positive 13 over 7. And that is going to be our limit value. So the way we write this is that the limit as x goes to -3 of our original function is going to be 13 over 7. Because this function was the exact same as before. So you can see that this function that we got whenever we factored out, remember that one trick that we use to simplify things is to multiply by the same thing on top and bottom. So essentially, we can multiply this by x plus 3 on top and bottom, and we're not changing the value because we're multiplying by the same thing on top and bottom, which is the same as multiplying by 1. So that's essentially what we did. So that limit value is going to be the same. Next, we are going to go to our second example where, again, our first step is going to be to evaluate the function at that limit point. So remember, I'm talking about the limit point as what x is going to in that arrow. So first, we're going to do the square root of 1 minus 1 over 1 minus 1, which is going to be 1 minus 1 over 0, which is again going to be 0 over 0. So as a word of caution here, you can see that I went ahead and simplified my denominator first, and I could see that I would have a 0 in the denominator. Don't stop there. So don't stop at this step and just say, oh, well, that's undefined because there's a 0 in the denominator, because whenever we finish simplifying the numerator, we also have a 0 there. So this is actually going to, again, be an indeterminate. And so we are going to, again, try and cancel out x minus our limit point. So we're going to try and cancel out an x minus 1. However, you can see that, well, there's an x minus 1 in my denominator, but I don't see a way to factor, especially with the square root in my numerator, to try and get an x minus 1. So instead of doing that, we're going to rationalize. And this is going to be a common strategy whenever we have a square root. We're going to multiply top and bottom by the same value. And it's going to be whatever that expression was that has a square root, where it's going to be a square root plus or minus something, we're going to multiply, where if we started with subtracting, now we have adding. So we're going to multiply these two things together. So I'm going to FOIL my top. So my top is going to be my first, so the square root of x squared, my outside plus the square root of x, my inside minus the square root of x, and then my last minus 1. And what I'm going to do is I'm remembering that I'm going to try and cancel out -1. So I'm going to leave, an x minus 1. I'm going to leave my denominator factored because I know I'm going to try and cancel out that x minus 1 that's there. So whenever we rationalize, our numerator, our middle terms should always cancel out. And that's how we pick what we multiply by. And then whenever I do the square root of x squared, I'm just going to get an x because my square root and my square are inverse operations that are going to cancel out. And now, magically, I have an x minus 1 on top that's left over and an x minus 1 on bottom that I can cancel out. So whenever I cancel out factors on top and bottom, that's kind of the same thing as dividing x by itself. Or if it makes you more comfortable, we're really just dividing, for example, 2 divided by 2, and that's going to give us 1. So we're going to have a 1 left on top, and then a square root of x plus 1 in the denominator. Now we can evaluate this new function at x plus 1. And my denominator is going to simplify not to 0 anymore, but to 2. So now I got rid of the 0 in my numerator and my denominator, and we're going to write this as the limit as x goes to 1 of my original function, because all I did was multiply by the same thing on top and bottom. And that's going to give me 1/2. So this is a different strategy to try and cancel out x minus that limit point if factoring isn't going to work. So as our last example, we're going to kind of switch gears and look at trig functions instead. And the way that we simplify trig functions is going to be typically through trig identities, or remember, like we talked about in the last video, we're going to specifically use these two trig limits. So if I have a sine, I try and get a sine of x over x. And if I have a cosine, I try and get a 1 minus cosine x over x. So those are our strategies for trig functions. So again, we're going to go ahead and start out the same way. We're going to try and evaluate this at our limit point, which is 0. And so I'm going to remind us when we plug in 0 into sine squared that the sine is what's being squared. So we evaluate the sine before we square it. So this is the same thing as sine of 0, all of that squared, divided by 2 times 0. So if we are remembering our unit circle, then we are going to know that the sine of 0 is 0, and that 0 squared is 0, and 2 times 0 is 0. So again, we're going to get an indeterminate value. So depending on your instructor, they may have different standards of how much of the trig unit circle evaluation you need to know. I would say that it's a general good rule of thumb to know sine and cosine of the major angles, which are 0, pi over 2, pi, 3 pi over 2, and 2 pi, just as a good rule of thumb. So we get 0 over 0, another indeterminate value. So we see that we have sine squared on top, and remember that anything squared is just multiplied by itself. So we're just going to split this apart. So we're going to say that sine squared x over 2x is really the same thing as sine of x times sine of x over 2 times x. And what I'm going to do is I'm going to split this fraction right down the middle. And I can do that because we're just multiplying two different fractions together. So I can only split it apart like this if I don't have any addition or subtraction. I just have multiplication and division. So I split this into two different fractions. So now this is actually all the simplifying we're going to need to do, because again, we're going to take the limit of these fractions. So this is actually going to work a little bit different than the ones before, because we're actually going to say that the limit of a product is the product of the limits. So remember that if we can split the function we're taking a limit of into a product of two different things, we can just apply the limit to each of them individually. So first I'm going to take the limit of sine of x over 2. Then I'm going to multiply and take the limit of sine of x over x. So the limit of sine of x over 2, we're just going to plug our 0 into our x. So this is going to be sine of 0 over 2. And then our second limit is going to be our special trig limit. So remember that sine of x over x is our special trig limit, which if we reference above is going to equal 0. And then we're going to have that this is multiplied by 0. And so sine of 0 is going to be 0 over 2 times 0, which is 0 times 0. And contrary to what we've seen before, 0 over 0 is indeterminate, but 0 times 0 is just going to be 0. Okay. So that's going to be our final answer. So I'm going to go ahead and box all of the final answers we had. And you can see that we started with 0 over 0 for all three of these examples. However, only for our last example was our limit value actually 0 or undefined. A lot of times that 0 over 0 will come out to some kind of funny looking numbers. It may be a little bit different. So that's going to be it for this video. We hope these examples help, and good luck.